Hi. So in this module, we are going to compare the three different types of regulators that we have explained earlier. So we are basically trying to provide a summary here. So you have the standard regulator where you see that we had this Darlington pair and there was this PNP transistor. So the dropout voltage, that is your input and your output, the voltage differential was about VD, and it was equal to two diode drops plus the saturation voltage of this PNP transistor. And usually in the regulator IC, when you buy it, it is estimated to be between 1.7 volt to 2.5 volt. So it's quite large. However, the ground pin current that we have understood what is a ground pin current is less than 10 milliampere. And the third part is the maximum current it can deliver to the load when you connect the load to the output is about 10 ampere. On the contrary, we understood that low dropout regulator, where the differential between V in and V out is just a one saturation voltage of this PNP transistor, and it's usually between 0.1 to 0.7 volt. So you can see that this dropout voltage right here is maximum 2.5 volt. Here is maximum 0.7 volt. Again, the ground current, however, in the LDOs is maximum 40 milliampere, whereas the load current is 1 ampere. So in a load specified, if you have a current requirement about 1 ampere or less, go for LDO. If you have a dropout voltage of very low value, then go for LDO. And we are going to see that when you can use standard regulators and the LDO. But is there a choice to us to have the regulator with the parameters in between the standard regulator and the LDO? Yes. So that is called as quasi LDO. So it's semi LDO. So what is the modification here? Instead of Darlington pair, what you see is a single NPN transistor, and you have this PNP transistor. So the VD, the dropout voltage, is of course the one diode drop of this transistor plus the saturation voltage of this PNP transistor. So VB plus PNP saturation, and it is usually between 0.9 volt to 1.5 volt. The ground current is less than 0 milliampere. No, let me check once again me for that. So let me correct that and write here. It is less than or equal to 10 milliampere. So you see the ground pin current of this regulator is in between the standard and the LDO. However, and of course the IL max is between the standard regulator and the LDO. So this is the in-between choice if you want to use your parameters. So now the question is when to use the standard regulator, when to use the low dropout regulator, and when to use the quasi LDO. So usually the standard regulators are usually best for AC powered application due to their low cost and high load current. If you have a requirement of high load current greater than or less than or equal to 10 amperes, so standard regulators are best. The reason you see that you have a AC transformer here, and then you basically have a AC voltage here, and that converts to step down or step up secondary voltage in the AC, and then you use the rectifier actually. Then you use the filter, and comes then the regulator. Then comes the regulator here. So for that AC powered application, you can use the standard regulator. Okay. Because in the AC powered application, the voltage across the regulator is usually at least 3 volt. Is at least 3 volt. And so the dropout voltage is not a problem here, is not critical. So even if you have a large dropout voltage, like we said, the dropout voltage in standard can range from 1.7 to 2.5. So you can do that. And in this type of regulator, the dropout voltage can be more than 2.5 volt as well, up to 3 volt, for example. So in such case, standard regulators are actually more efficient than the LDO, because the standard regulators have less internal power dissipation, because their ground pin current is less than the LDO. You see the comparison here. Now moving to the LDO, for a battery powered application, go for LDO, because you see that in a standard wearable devices nowadays, we have ultra low power circuitry inside, and the devices are powered with a single or multiple battery cells, usually 1.5 and multiples of 1.5. So in that case, the lower dropout voltage of the LDO, which is usually between zero point 0.1 to zero point 0.7, translates directly into the cost savings, because you reduce the number of battery cells. If you have like 1.5 volt at the input from the battery, you can go for LDO, not the STD, that is the standard. So if the input output differential is low, like 1 volt, 2 volt, you can use LDO more efficiently than the standard regulator, because now low dropout is translating to low power dissipation, resulting from the load current multiplied by the input output voltage differentials. So the power dissipation is basically your product of your product of your dropout voltage into the load current. So the load current, even though it's is also low, up to 1 ampere, and the dropout voltage is also low, up to 0.1 to 0.7. So the power dissipation in a battery applications, LDO will be much more efficient.